I think everybody knows us both at this stage. We've both already been on stage, so I'll skip the intros and dive into it first. So why this talk? Why are we talking about doing less by default? Surely we want DPDK to get bigger and better and to do more generally. But the key thing here is, as was mentioned, the topic of consumability. I'm reusing the chocolate cake picture from the broccoli talk, as it's become affectionately known. So the overall objective is to make it easier to take bits of DPDK and to integrate them into your application, to effectively fit DPDK into an existing code base. Because let's be honest, most people writing an application using DPDK are not starting from scratch, starting with brand new C files. They've got a whole body of existing code that needs to be made to work with DPDK. So in that case, you don't want an all or nothing approach. You want to be able to take the individual parts of DPDK that you want, generally the pull mode drivers and a few other core libraries, and plug them in with as little disruption to your existing code as possible. Okay? So you want to be able to also take existing functionality from other places and plug that into your DPDK application later as well. So DPDK just needs to play nice with others to be more consumable. Okay? So for the topic that we're talking on here, for my opinion, since Thomas and I are both very opinionated about a lot of things, but we're generally agreed on, I think, on most of the stuff here, since we're doing a joint talk about it. But for me, really, the key phrase here is by default. Okay? What we want to have in DPDK is something like a buffet. Okay? You want to have a wide selection of components that are there to be used, but you don't want to force everybody to use them. You want to have them available, but not there by default. So that's why the by default phrase, I think, is key. It's not saying just DPDK needs to do less. Generally, DPDK can go on doing more. DPDK can go on and including the IPsec library, can go on including new device classes, can go on including new drivers, but you don't want to just force them on everybody because that's then going to break somebody else's app. If they've already got IPsec in their application, you don't want the DPDK IPsec library to suddenly come and interfere with all that and screw up their crypto driver usage. Okay? So the overall aim is to ensure that we don't break things, and the other side is to make it possible to have things commonly available. Okay? So if we provide a solution for, take again, IPsec in DPDK, hopefully that'll be useful for a lot of people, and that'll be the default IPsec implementation. Where this becomes even more important in my mind is when we talk about things like cores, which I'm going to talk on later in this presentation, and core management and perhaps memory management and the like, is that sometimes has external constraints. It was like the questions, the tough questions I was putting to Thomas earlier about how does a system administrator deal with all this. So if you have a default method in DPDK of managing things, well, if 80% of the applications use that default method, then if you've got an orchestration tool or a system management tool used by a system administrator, that tool can then be enhanced to work with that default method, and you've again got 80% coverage of your DPDK apps. There'll always be outliers, okay? Because some people have already got existing code that wants to do things their own way, and we've got to keep on supporting that. But on the other hand, we do want to perhaps provide default options so that you can get coverage from external tools, particularly thinking about those kind of orchestration or system management tools. Okay? So we want to make sure that the tools have a path to work with the majority of DPDK applications. That's kind of the two sides of the coin in this vision of do less by default. So, Thomas, going to talk about options.
Yes, we examine the options. Okay. So basically, this talk will show some issues that we have and how we can solve them. They are just examples of what we can do to do less by default. So first one is about options. A lot of users of DPDK are complaining that our options must be passed to the function RTEL init in the way argc argv. And it's a problem because if you just take it from the application command line and give it to DPDK, it's fine. But if you want a different command line in your application, if you want to change the option, tweak some, add some, I don't know, it will be hard to do. Yeah, so it's not easy to consume this part of DPDK. The other issue is that some options of DPDK are configurable only through this API. There is no simple API function just to change one setting, like for memory, these kind of things. But there is one benefit to this API, argc, argv, because application writers doesn't want to manage to tweak in the option to translate them, so they just use the option parsing, which is provided in DPDK, and all DPDK applications mostly use the same syntax for command line option. We can see it as a benefit. Okay, so we want to change that. We want DPDK to be better consumable. One suggestion is to provide some new function to provide the option. One is exactly the same as today with the argc, argv, if you still want to use it. Or you can give a simple string with all your options. Or a more fine-grained function would be to give the key of one option with its value. So this way, you can get the option from anywhere. You are not forced to use the DPDK default syntax. You can get it from a file. You can get it from OpenStack configuration, or I don't know. OK, how it would work? Well, you give your string to the function, and at the end, you get it parsed and stored in a kind of database. We can think at a big structure to store all options of all DPDK parts. One important thing is that we don't want this library to bypass the other API. We don't want to configure everything through this API. It's just a convenient way to parse some options from somewhere. So DPDK libraries should not use directly the values which are stored in this database. This database will just store what is parsed, and then the application can reuse it and parse to the right API. OK, now that I've said that, there is one exception. Because at the same time, we want to simplify how EL is initialized. And one way is to use this new library. You can use it or not. But if you use it, you could use one function which would be RT default init, for example. And this function will get the option for EL initialization, like memory, this kind of thing. Will get the values in the database, and if there is no values, it will get some default values. Remember, the title of the talk is less by default. So you get some defaults too, and then we have to choose some good defaults. And maybe after that, we could deprecate RTEL init function. That's a proposal. OK. There is more. Yes, I already talked about the devarg syntax this morning. This devarg syntax can be used in several options, like whitelist or other things. So probably we will need to use this new syntax. And one consideration which is very important, we try to do it now for, I think, for 1 or 2 years. We're progressing well, but we must do more. We must remove all build time options. We have a lot of build time options. Again, you know, DPDK in the past was only a bare metal framework, so all was configured at compilation time. Now we want it to be packaged in distribution. Distribution package it with one build time configuration, so it's not a good idea to put your option at compilation time. So now it's clearly forbidden to add this kind of configuration at compilation time, and more, you should work to remove those which are already existing. That's all.
Yep. And just for me as a plug, since most people know I'm plugging the new Monjalon build system in DPDK, if you look at that code there, you'll see there's very, very few build time options in it, and we would really like to keep it that way. So if you're porting your driver over, please try and avoid putting in any build time settings when moving it over. It should be all by default with a single setting that the packagers can use. The other thing I'd say about all this is these are suggestions, as each of the title slides say. So we really like to get some feedback and some discussion at the end of this talk to get other people's opinions on it, because these are touching some of the key parts of DPDK, options parsing, and now I'm going to talk a bit about core and thread management and some ideas there, and again, problem statement, because we're all aware mostly of the problems. So in a nutshell, it's again this whole thing of DPDK being greedy, okay? DPDK wants to manage all the cores and threads itself. So what happens right now with DPDK if you don't pass in a core mask in the EAL args? It goes and spawns a thread on every single core in the system. So if you're running, a system with 72 logical cores on it, and you run testpmd and don't give it any arguments, testpmd will happily make sure that there's 72 threads available in DPDK for you to use, which is, excessive and greedy. So DPDK essentially, for sane behavior, it requires a core mask for EAL init. Even if you're spawning no threads. So if you just want to run your L2 forward example, just using a single logical core, you still have to specify a core mask for that. And the DPDK EAL is going to go in and change the thread affinity for that master thread to the core you specified in your core mask. There's no way right now in DPDK to say, I'm just going to have a single threaded DPDK application, and I've already set up the threads exactly the way I want. Don't go and touch anything, okay? Or to take the flip side, if you've got an already existing large multi-threaded application that sets up the threads exactly the way it wants, and then you go and plug in EAL init, how can you go about doing so such that EAL doesn't go and muck up all your existing carefully crafted thread management? So I think most people are already aware of that, but that's basically the problem I think that we need to solve here. So sadly, there's nothing currently in RFC stage on the mailing list or V1 stage to look at this. So again, I'm throwing up some suggestions as to how I think that we should go about solving this. Some of this is quite easy. Other bits of it, maybe it may involve a little bit of work. But again, I'm looking for feedback on it. And hopefully somebody else will just do it, as my t-shirt suggests. So first thing is, I think we should allow 0 as a core mask in DPDK, implying do nothing, because currently there's no way to have that in DPDK. Okay, so if you specify -C0, 0-bit set, don't use any cores, it should really mean don't spawn any worker threads and don't go changing the thread affinity of the master core. So this then gives you a path to call the EAL init and not have it worry about what it's doing with threading. It essentially does nothing. Furthermore, and I realize this is an API or ABI break, okay, I think we should change the behavior for running DPDK without a core mask. I don't think for consumability that having DPDK spawn a thread by default for every core in the system is sane behavior anymore, okay? Maybe it was in the days where you had dedicated boxes that was just running packet processing and you did want to run all cores. Really, I think that should be changed to a do-nothing default. Okay, and I think that's the attitude we need to have for just about everything in DPDK. Unless you're explicitly told to do something, don't go do it. So those two should be fairly easy changes to make, I hope, in DPDK. And if others have other ideas for similar behavior, feel free to shout it out at the end. What's more interesting is how do we make DPDK more like a library and less like a framework when it comes to thread management itself, apart from the whole core mask part. I suppose you want to do dynamic thread management in DPDK. Okay, how do you go about doing that? Okay, because it's set up to be very, very static, as was called out earlier. You pass in your core mask, you get your threads, that's it, you're done. How do you add threads? How do you remove threads? So possibly one solution might be for us to add a set of explicit thread management APIs into DPDK. So this is some idea, or an idea I have of how they might work. So possibly you'd have a thread init. So suppose you initialize DPDK with a core mask of 0 or no core mask. Then you do want to add a thread in. Well, DPDK threads, if you want to use remote launch and the DPDK spawning APIs to spawn the functions that way, you need to set up certain resources, assign an L-core ID for each thread, which is generally needed to work with DPDK objects. And then for remote launch to work, you need a FIFO to pass function pointers through. So there's a few things like that, nothing too serious. So we probably want something like a thread init call, which would allocate the L-core ID, allocate the FIFOs. Now, I suspect it probably needs to be called on the thread itself that you're adding, but that's hopefully not too big a limitation. But that would set up a thread, so it could potentially be used by DPDK. Thereafter, to actually have it used by remote launch or remote launch MP, those functions that we know for spawning DPDK packet processing related tasks on cores, you then might have a process API which says, right, now go do some DPDK work. And I actually think if we do this, we should implement perhaps 2 copies of these. One would be the process call, which says, right, go use this thread for DPDK, and it runs forever, like the existing threads do whenever you have them spawned by DPDK EAL. But I also think we should have just a single shot version that says, go process 1. So go take a function pointer, if there is one, from the FIFO. Go run that packet processing function for as long as it takes, and then whenever that function returns, come back to the application. So that then would allow you to have an application go do some DPDK work, do some packet forwarding work, and then if you want to scale down your application, you can take it back and have it maybe switch to doing control plane work for a while. It's not giving it forever to DPDK. It's, again, making it much more dynamic. And then we'd probably need some sort of cleanup function. So these are just one suggestion on how thread and core management could be changed in DPDK. Okay. The other thing, though, that I want to put out there as a consideration for this work as well is how do we allow orchestration as well and external control of this? So it's all well and good the application deciding, right, I want to scale up. I want to now use an extra 2 cores on my system, so I'll spawn an extra couple of threads and give them over to DPDK use. But in the cloud world out there, or in VMs or shared systems, you may have 2 applications running where you want to, on the system level, say, right, application A, I want you to go free up 2 cores, and application B, I want you to go and take those. Okay? Now, there are a couple of requirements for us to put support for this into DPDK. One, we probably need some sort of common or default orchestrator to apps or system management communication mechanism. That's a whole separate problem. And I know some people are thinking about that as well. I know Keith Wiles has got some suggestions on how you might do system management and orchestration communication to applications. But if we had that, okay, we need to then think about hooks into applications to flag them of these notifications. So an application gets told, okay, the system administrator says you can go and use 2 extra cores. Okay, so we need a way to flag that into the application, and then the application possibly could use those additional dynamic APIs. Okay, similarly for scale down. But it really needs to be done via application hooks, because spawning off 2 threads in DPDK automatically just isn't going to work, because the DPDK isn't going to necessarily know what function to call on them. And even if it did, if you're, say, running L2 forward, to take the most trivial example, and you're saying, run just L2 forwarding on every core. You spawn off 2 threads and go to run L2 forwarding on every core. Well, how does that core know which particular ports, which particular queues is going to use? The application has to control it. So that's a sort of further down the road consideration, is it can't just be the application in control itself. We need to take account of the fact that external entities are also going to want to signal to the application and control things that way as well. Okay? So that's some additional food for thought, and I don't have a ready-made suggestion for that. But again, I'd love to discuss it with people afterwards too. Okay, constructors.
Thank you. So you talked about being more dynamic with CPU allocation, scaling up, scaling down. Earlier you talked about hot plug memory, and I talked about hot plug devices. It looks like DPDK wants to be more dynamic. Isn't it?
Almost got that.
Yeah.
Almost get that.
Yeah. Okay, hopefully next year we won't talk about that and it will be fully dynamic. We need help. Okay, let's talk about constructors quickly. Just a reminder, what is a constructor? You see attribute constructor, it means it is an attribute for a function. It means this function will be called before main. And it's always called. This is the issue, actually. The issue is said as DPDK cannot be fully disabled. Okay, I will explain. So we have a lot of constructors in DPDK. And we can have some applications which are packaged with DPDK, which means linked with DPDK, but sometimes wants to disable DPDK at runtime. Let's say, for instance, the hardware is not supported for DPDK acceleration. So I just disable DPDK. And unfortunately, if hardware is not able to run DPDK, maybe it means the CPU is old. And on x86, if you are running on a CPU older than SSE 4.2, I know this is a very old machine, but it won't work because DPDK is compiled at minimum for SSE 4.2. So what happens? You will run some illegal instructions. And the thing is that we can have such illegal instruction in our constructors. But unfortunately, you run this illegal instruction, but you don't want to run the constructor because you disable DPDK. You did not enable DPDK, but constructors are always enabled. This is the issue. So what can we do? At first, for sure, we need to forbid the new instructions in the constructors. So the solution is to use another attribute, which is attribute target something. We can say default or SEC2 or anything. So it will run on any machine. But that's not all. That's only part of the solution. Then we will have problem with the functions which are called inside the constructor. Okay, you will say, but a constructor should be small. You should not call any function in a constructor. Yeah, maybe, but it happens that we are calling some function in constructors. So now we need to apply the same attribute to every functions which are called by the constructor. And obviously, the function which are called by the function which are called. Okay, you get it? So it's hard to maintain. And each time we will call a new function, we will have to apply it again. So there is another option. Okay, full disclosure, Bruce prefers option 1. I prefer option 2.
Yeah. I want to know what our constructors are doing. So I like option 1 because it'll force us to keep them small. But as you say, it is harder to maintain. So
yes.
Is there any way we can put constructors in a different ELF space and do something gross like, you know, conditionally, like, oh, you're calling out of your space or something. I don't know.
Yeah.
Or use tools to audit them afterwards.
Possibly, but we don't want to use a sledgehammer to crack a nut either. So, yeah, could be an option 3 or 2A or 1A or whatever it happens to be. Yeah, sorry.
Okay, I will explain option 2 because to me it's interesting. We have this macro RT init, which is used for constructor. Inside this macro, we can insert another function which is calling RT CPU is supported, and then if it's supported, we call the actual constructor. If the CPU is not supported, we stop it. We skip the constructor. So in the case we have an old CPU, we will have no crash. Simple. More considerations about constructor? Okay, maybe we can question the use of constructor in DPDK. I heard in the past more issues with constructor, so it's open to discussions. And something else open, maybe there is a solution to convert the constructor to real functions, which are enable or disable, something like that. It's totally open. Okay, next topic. This is yours.
Yeah, absolutely. This is us finishing on episode 5, which, as everybody knows, was the best of the episodes. So that's about it. So thoughts, comments, and suggestions on what we've just proposed. How much stuff are we going to break?
Okay, so I had one question. can we not keep EAL init, but have it just parse the arguments, fill the database, and call RTE default init? Because I don't understand why we desperately have to have a new API and deprecate the old one, I guess.
Yeah, okay. I can talk again about it. Can you show the slide maybe?
I can try.
First of all, we could say we just want simple API. So we could say remove RTEL init and just let the application call directly each function to initialize each part of DPDK. But the issue with this approach is that the order of initialization is very, very important. You cannot imagine how many fixes we have to put things in the right order constantly. So we need to keep one big function to preserve the right order of initialization. But at the same time, we don't want to have this big argc, argv option passing. So what do we propose to change it? We can get the options from somewhere else. Actually, it's open. We just want to make it simpler.
I guess the point is that EAL init can just not do that big function processing, right? It just processes the arguments, fills in the database, and calls default init, right?
Yeah.
Yeah,
And
I mean,
do the same thing.
yeah. If this, let's say, if we implemented RT default init and the new library, as Tomas is proposing, then EAL init could become exactly that, a wrapper around your options function and your default init.
Exactly.
Now, this is a suggestion. I mean, we did discuss this, and hence the question mark at the end as to do we want to consider deprecating EAL init, which would also then have the effect of pushing people towards a newer way of initializing things. And think of all our sample apps. If we don't deprecate EAL init, chances are we're not likely to update all our sample apps to give a more app in control of the arguments style of doing things. So it's
all we're doing is changing the underlying layer as to how it's done. And we could go and change all the apps to use default init. I don't have a problem with that. What I'm suggesting is all the other people in the world, they may have a problem, right? So we need to keep a backward compatibility instead of just deprecating things off willy-nilly is my point.
Yeah, point taken.
Hi, Bruce. I have a very simple question for actually the command options. Because currently our command option for some application already became extremely long. Some of them is insane long, parameters. And we have the EAL specific parameters. We have the application specific parameters. Is there any probability that we can introduce some simple like JSON config file, to hold that instead of I put into command line too long, Okay,
yeah,
thank you. Yeah.
Absolutely. Okay, sometimes we say we want to do less. Sometimes we want to offer more, but not by default. For the configuration file, it's difficult to decide because yes, we feel there can be a need to have a standard config file for DPDK, but at the same time, every application will want to use their own config file. And at the end, the question is it really the responsibility of DPDK to provide some config file facility? I don't know, but for sure, with this option, RT-opt, RT-opt parse KV, you can build what you want. It will understand the keys. This is the most important part, I think. Then what is the config file? It's just a list of key values. So probably the work will be very easy. Is it really worth to put it in DPDK? Open question.
Yeah, I entirely agree with that. I think the parsing of the arguments itself should be left to the application, and the application should decide whether it wants to use a JSON config file or an ini config file. I mean, we have the ini file library in DPDK already for providing your ini files. Okay, other apps may want to use JSON. That should be an application choice. The application can parse that and then use this parse KV that is proposed here, just to fill them into that database that is known by EAL init. So it's again keeping the app in control, and the app decides what config format it wants to use. I don't think we should go down the path of EAL libraries themselves needing config files. It should be an application config file, and DPDK only takes it via APIs. Wasn't that one of your key points? Is we want to have APIs for everything, not just send it in as a big collection of static strings.
There's a question there.
All right. Yep. So I think this presentation almost feels like an answer to some of the things I was going to bring up in my presentation tomorrow. So it seems like a lot of this alleviates a lot of the issues that I've had with URDMA. So I guess I just had a couple comments. So one of which, when we're talking about the core masks and everything, so one of the other things to think about with that is with multi-process applications where you have the requirement that L-core IDs are distinct between different processes in the multi-process application. So that should probably be factored into whatever new L-core thread API that you would come up with. And then I guess my other thing with the constructors is that's also another issue that I've run into. And so kind of it just generally feels to me like if constructors are relying on having all of these CPU features available, it kind of feels like maybe it's just too much work is being done in constructors as opposed to being done by the init function. Yeah, I guess just maybe more so just comments than questions, but yeah.
Actually, I think just on the constructors one, it's not so much that the constructors themselves need these instruction set levels, it's more that the compiler is compiling them assuming that instruction set level. So it's inserting these instructions into the stream. So whenever you then have your OVS or your application, which is looking to see what a CPU is and can decide whether to use DPDK or not, it's crashing before it even gets to that point because the constructor is running, which doesn't need SSE 4.2, but the compiler has inserted some SSE 4.2 instructions into it, despite the fact that they're not actually needed. So I think that's probably the core of the problem there for the constructors. That this is why specifying the minimum version should work around that.
So one of the things I've been told is that constructors and deconstructors don't work in some compiler systems, like in Windows when they're building Windows, for DPDK. So we either have to move away from constructors or figure out some other mechanism to make it work, right? And constructors serve two purposes. They try to do some sort of order of initialization, a very, very primitive one, whether we do a high, low, or some number, right? And that's the other problem that we have is that things need to be initialized in a certain order. And we probably should assign that ordering to the entity itself, not to a constructor keyword type mentality, right? So that you can actually initialize things correctly without this, through the complete system, without having necessarily to add yet another constructor 101 or 102 or what have you. So I think we ought to look at trying to get rid of constructors altogether.
Yeah, it would be great if we could come up with an alternative. We were starting to discuss that a bit last night when we were going over these slides. I don't think we came up with any good solution because one of the big things that constructors are used for is for that registration and initialization time of things like drivers. Okay, so it'd be great if you could call into every driver to say, go register yourself, but without that initialization init constructor callback to register the driver, you don't know what needs to be registered. So it's kind of a chicken and egg problem, and this is where the constructors come in, that the SOs themselves, as they're loaded, call in and register themselves as I need to be initialized. And that's, I suppose, the big gap that we have on the constructors right now.
Yeah,
so if there are solutions to that, great.
Yeah, there's no easy way to replace constructors. You either have to scan the objects and find some special function name, or you have to put them all into a section of the ELF file to execute. In a previous life, we built a DAG graph of all of them and then executed the DAG graph correctly, right?
Yeah,
and that's how we got
because the other thing to remember is that not all the drivers are going to be available at build time. More can be plugged in. So I don't think we've got any of the Windows guys who are looking at DPDK on Windows here, so maybe they will come up with some alternative then we can reuse in other places too. Yeah. So.
No more question? Ilya?
I have one question regarding zero CPU mask. You're saying that not spawning any workers and do nothing. So actually, a question regarding vhost thread, interrupt handle thread. Are you expecting that user will run them by hands, or how it should work?
Yeah, I deliberately left those out. I was originally going to say don't spawn any threads, and then I thought, well, do I have a good solution for the interrupt thread and any other background threads? And right now, the answer is I don't know. I haven't tried implementing this. We may still need to spawn off a background thread to handle interrupts. The thing is that is not pinned to a core. It's not affinitized. It is just another generic thread that runs on the system. So hopefully that will be acceptable. I suspect that having core master 0 support, not changing the affinity of the master thread, and not spawning any worker threads that are pinned would be a good first step. Then maybe we can see if we can get rid of some or all of the additional interrupt threads or anything else that that could be done, that is currently being spawned off. I don't have a good answer to that right now, I'm afraid.
Okay.
Okay, maybe I have one more question. First to comment, I really liked this presentation, Bruce.
Sorry?
I liked this presentation, it was very good, thank you. And one comment, does it mean that you and me are going to implement all these things?
Absolutely, of course. Us and a whole army of developers we have right here. Okay, so volunteers needed.
So these are ideas, just to show one path. If you are interested in one of these problems to solve, please be volunteer.
Yeah, and some of them are not going to be hard, one hopes. Famous last words, eh? So.
We'd like to see the community, step up and help. That'd be good.
Yeah, and please let's have more discussion about this here on list, what have you.
Do they just approach you to ask you if they want to help you on one of these topics?
Yep.
Yeah, of course. Of course. We just don't have time to implement all this stuff, but we can help. Yeah.
Okay, thank you.
Thank you.
Thank you.